Hello and welcome to my channel. I am Mensan Augustine. If you are new here, kindly subscribe to my channel. And if you have been watching my videos and you've not yet subscribed, please kindly subscribe for us to build the mathematics community. In this lesson, we are going to evaluate limits using factorization. Thanks to Elizabeth Asumeluwa for requesting for video on limits. If you want me to do a video on any lesson for you, you can leave it at the comment section, or you can send it to my WhatsApp number +2332453607993. Wow. And if you have homeworks that you want me to help you, you can send it to my WhatsApp number. But please, if you are sending it, you have to send it to me on time. You have to send it to me on time. Other than that, I may not be able to help you, but I have to help you, and it is free. So if you want to send it to me, you send it to me on time, so that I'll also get time, look through it, and then provide you the necessary assistance that I can. Okay, so we are going to look at limits using the idea of factorization to evaluate the limits. And don't forget, if you want to support my channel, this is my mobile money account number. So you can donate to my mobile money account number to support my channel. My name is Mensan Augustine. Let's take the first question. We are going to consider x cubed minus 8 divided by x minus 2. So the limits as x approaches 2 of this function. So we are taking the limit x cubed minus 8 divided by x minus 2 as x approaches 2. How do we evaluate this limit using factorization? Now, we have to do direct substitution and see the results. So upon direct substitution, 2 cubed is 8. 2 minus 2. Now, we have 0 divided by 0, which is indeterminate. Now, if this happens, then you are lucky. It means that we substituted x equal to 2. So, if we bring this 2 here, we have x minus 2 equal to 0. It means that x minus 2 is a common factor to the numerator and the denominator. So we have to factorize the numerator to get a factor of x minus 2 there. But here we have x minus 2 there and the denominator. So we don't have problem with the denominator. So we maintain the x minus 2 and then factorize x cubed minus 8. Now, how do we factorize x cubed minus 8? That is what we will be looking at. Okay, so if you have x exponent n minus a exponent n, where n is odd, we are going to use this expansion. We have x minus a times x exponent n minus 1 plus x exponent n minus 2 times a plus x a plus a exponent n minus 1. That is what we are going to use for our expansion. And that is n minus 2. Here it will give us n minus 2. Oh, the board is, I hope you can see, it's the same as x minus a times x exponent n minus 1 plus x exponent n minus 2. Then I'll bring a plus I'll take x exponent 1, a exponent n minus 2 plus a exponent n minus 1. Okay. Wow. So remember that if we reach here, it is x exponent n minus n. That will give us x exponent n minus n, a exponent n minus 1. And here is x exponent 0, a exponent n minus 1. That is why we have a exponent n minus 1 there. Okay. So let's expand this. This is the same as x cube minus 2 cube, which will give us x minus 2 times x exponent 3 minus 1 is 2 plus x exponent 3 minus 2 is 1 plus 2 exponent 3 minus 1. So you take that one, that will give us the dot means that if the power is bigger, you keep on going till you reach the n minus 1. So here you take x minus 2 times x squared plus 2x plus 4. That is 2 squared, and 2 squared is 4. So you take 4. Very simple as that. Okay, so we are going to have the limit as x approaches 2 of x cube minus 8 divided by x minus 2 to be equal to x minus 2 times x squared plus 2x plus 4, all divided by x minus 2. So here the common terms will cancel out, and have the limit as x approaches 2, x squared plus 2x plus 4, which is the same as the limit of x as x approaches 2 squared plus 2 times the limit of x as x approaches 2 plus the limit of 4 as x approaches 2. So here this will give us 2 squared plus 2 times 2 plus 4. So this will give us 4 plus 4 plus 4, and that is 12. Wow. Very, very simple and very, very interesting. Now let's move to the next question. We are solving more examples to improve your understanding. Yes. Let's see the next example. The next example, we are going to take the limit as x approaches 9. Then you will take 3 minus square root of x divided by square root of x divided by x minus 9 versus the limit of this one is the other one. There's 3 minus square root of x, and this is x minus 9. Okay, so versus the limit of 3 minus square root of x divided by 9 minus x as x approaches 9. So let's take the first one, or let's take the second one. Let's take the second one, because the second one is very, very common to ask. But before we simplify this, remember that, before you evaluate this, remember that if you have x squared and you take the square root of this will cancel this and it is equal to x. So we can state that the square root of x squared is the same as x. Very simple as that. And the square root of x squared like this is also equal to x. Very simple as that. So here we have the limit as x approaches 9. Now let's put in 9, direct substitution, and see what we are going to get. You have 3 minus root 9 is 3 divided by 9 minus 9, which is 0 divided by 0. That is indeterminate. Wow. So here, upon direct substitution, we are getting 0. So what does it imply? It implies that we are going to have a common factor. And what is that common factor? Let's figure it out. Let's figure that common factor out. Now, if we take you said you do the first one, the second one first, huh? Okay, so let's take that one. So this is 3 minus square root of x divided by 9 minus square root of x squared. Yes, that is what I've explained here. So here you have the limit as x approaches 9. 3 minus square root of x divided by 9 is 3 squared minus square root of x squared. This is the same as the limit as x approaches 9. 3 minus square root of x divided by 3 plus square root of x times 3 minus square root of x. That is difference of two squares. I have a video on difference of two squares, so you can check the description for that video. That is, if you take a squared minus b squared, it's the same as a plus b times a minus b. Or since multiplication is commutative, you can write it as a minus b times a plus b. So that is what we've used. Here a is 3 and b is root of x. So that is what we've done here. And here this one will cancel this. So this will be the same as the limit of 1 divided by 3 plus square root of x as x approaches 9. So let's substitute. So this will be 1 divided by 3 plus square root of 9. That will be 1 divided by 3 plus 3, and that is 1 out of 6 as the final answer. Now, if you consider the first part, for the first part, we are going to do the same process here. So let's start the first part from here. So the first part will be the limit 3 minus root x divided by, this will be square root of x squared minus 3 squared. So we take the limit 3 minus root x divided by square root of x squared minus 3x squared as x approaches 9, equal to the limit 3 minus root x divided by root x plus 3 times root x minus 3 as x approaches 9. Now here, there is no common term to cancel out, but remember that if we put in x equal to 9, you will have 0 divided by 0, which means there is a common term. Now, that is why I love my mathematics teacher. He's called Abdul Rashid Mensan Selassie. He teaches at Mauli School, but I didn't go to school there. He taught me at Jenfiku Medini Secondary Technical. I is now a teacher at Mauli School. That is who in Ghana. He taught me very well. Now, I love him. You have to make your teacher proud one day. If it's not your teacher, your mom. That's why I'm mentioning my teacher's name in my video and where I went to school. So you have to become a good ambassador of your school. Don't be hiding. If you go to Facebook, then you change where you went to school. Somebody write, I went to school at but show your recipe. Let's go to business. Very simple as that. Okay, I have this student at Lincoln, Lee, Ayupak, Ebenezer, Roots, Harriet. Yes, they are doing BSc mathematics there. I love you all. Okay, so let's go to business. Now, if you have m minus n divided by n minus m, it's the same as factorizing negative out in one of them. So let's see. If I factorize negative out here, I'm going to get negative times. This is positive, so it will become negative m plus n divided by n minus m. See that? Negative times negative will give me positive m. Negative times positive will give me negative n. And we'll come back to where we are. So this is the same as negative into bracket n minus m divided by n minus m. Wow! And the numerator and the denominator has got a common factor that can be cancelled out for us to get -1. Check it out. Now, so we are going to apply it at the top here. So here I'm going to have negative into bracket -3 plus square root of x divided by square root of x plus 3 times square root of x minus 3. Wow! So we are going to get, let's bring the limit, as x approaches 9. Very necessary. So now we have the limit as x approaches 9. We have negative there. Square root of x minus 3. Just regroup what we have here. Divided by square root of x plus 3 times square root of x minus 3. And we have a common term that we can cancel out. So this will give us the limit of -1 divided by square root of x plus 3 as x approaches 9. Then we take the limit of -1 as x approaches 9 divided by the limit of square root of x plus 3 as x approaches 9. Because the limit of the quotient is the quotient of the limit. So here the limit of a constant is a constant. So you are going to get -1 divided by, if you put in 9, you get root 9 plus 3. That will give us -1 divided by 6. That is opposite to the second one. Wow! I hope you are enjoying the lesson. Keep watching. Okay, let's take another example. So I'll be doing a series of examples, that are different examples for you to get the approach to limits using factorization. Factorization. So let's keep on factorizing. Now our next question is this one. We have, what is the question? This is a very nice question. We have the limit of x squared minus 4 divided by s cubed plus 6x minus 20 as x approaches positive 2. Okay, so let's put in direct substitution. 2 squared is 2 minus 4. Sorry, 2 squared is 4 minus 4 is 0. 2 cubed is 8. 6 times 2 is 12 minus 20 is 0. So you have 0 divided by 0, which means we have a common factor. So what is that common factor? We have x equal to 2. The numerator will tend to 0 and the denominator will tend to 0. So it means that the common factor is x minus 2. So x minus 2 is common to the numerator and is common to the denominator. So let's figure it out. We've gotten the first factor. So here, the numerator, we have x squared minus 4, which is the same as x squared minus 2 squared, and we get difference of 2 squared, x plus 2 times x minus 2. Now, what about the denominator? We're able to factorize the numerator. What about the denominator? We have x cubed plus 6x minus 20. So this is a cubic expression. Now, x minus 2 is a factor. We know it already. But in case you don't know, how do we factorize this? We want to factorize this. You look through if there's a common term that we can factorize out. First, you do that. But here we don't have. So we go to the constant term. That is -20. So we find a factor of negative 20 such that when you put it inside this, the whole expression will turn to 0. And that factor, we've had it already, it is 2. So it means that x minus 2 is a factor of this, as we've said it already. So we are going to use a long division method to divide this to find the other factors. So let's do the long division. But before we do that, let's write what we've had. The limit as x approaches 2, x plus 2 times x minus 2 divided by, let's do this and then come and put it there. So here we are going to have x cubed plus 0x squared plus 6x minus 20 divided by x minus 2. Why this 0x squared? I've used this 0x squared to occupy the position of x squared. We have x cubed, we don't have x squared. So 0 times x squared is just keeping the position of what? X squared. 0 times x squared is 0, so there will be nothing there. So always, for example, if you have, let's say, x to the power 4 minus 1, and you're going to divide this by, let's say, x plus 2, what you have to do is that this is x to the power 4, so you have to fill the position for x cubed, x squared, x. So you take x to the power 4 plus 0x cubed plus 0x squared plus 0x minus 1 divided by x plus 2. This is just by the way, so that these places will be filled. Okay, you will see the significance of filling the places when we are solving it, when we are factorizing it rather. So here, x will go and divide x cubed, x squared. X times x squared will give me x cubed. Negative 2 times this will give me minus 2x squared. That is why I filled here, so that I'll put its slight term under it. So I'll subtract to get the remainder. X cubed minus x cubed is 0. 0x squared minus minus 2 is positive x squared. I have plus 6x minus 20. X will divide 2x squared plus 2x. X times 2x is 2x squared. Negative 2 times 2x is negative 4x. So I'll subtract to get the remainder. 2x squared minus 2x squared is 0. 6x minus minus 4x is positive 10x minus 2. Wow. So here x we divide 10x, positive 10. X times 10 is positive 10x. Negative 2 times 10 is negative 20. So I'll subtract to get the remainder. 10x minus 10x is 0. Minus 20 minus minus 20 is 0. So it means that in place of x cubed plus 6x minus 20, I'm going to get x minus 2 times x squared plus 2x plus 10. Somebody out there is asking, sir, if you are doing this section B question, will you do this? Yes, this is part of the question and it is called a hidden question. So this is the method that we use to get these factors. So if you don't use the method when you're doing your section B question, it means you are going to lose marks. But for section A, you can use a calculator to punch this, factorize it and put it there and just do your cancellation and go your way. So that is the idea. So we call this one a hidden question inside this. So here we cancel this and that. We are going to have the limit as x approaches 2, x plus 2 divided by x squared plus 2x plus 10. So we take the limit of the numerator and the limit of the denominator. So we have the limit as x approaches 2, x plus 2 divided by the limit as x approaches 2, x squared plus 2x plus 10. And upon substitution, we have 2 plus 2 divided by 2 squared plus 2 times 2 plus 10. That will give us 4 divided by 2 squared is 4 plus 4 plus 10. That is 18. And we have 2 divided by 9 as our final answer. Wow. Now, let's take the next question. Now the next question is this one. We have the limit as x approaches 1. X to the power n minus 1 divided by x minus 1. So if we put in 1, we're having 1 to the power n minus 1 divided by 1 minus 1. 1 to the power n is 1 minus 1 divided by 1 minus 1. That is 0. Wow. Why don't we say this will cancel this and we have 1. 1 minus 1 is 0. 1 minus 1 is 0. So you have 0 divided by 0, which is indeterminate. So it means that x equal to 1 means x minus 1 is equal to 0. So x minus 1 is a common factor to both the numerator and the denominator, but we have it at the denominator. So let's factorize it out from here. Now, so I'm going to put it down, the limit x minus 1 as x approaches 1. We are going to factorize it and then come and fill it here. So here, if we have done it already, if you have x as in n minus 1, the expansion is x minus 1 times, I have the expansion here, x exponent n minus 1 plus x exponent n minus 2 plus up to 1. That is the expansion that I have there. Yeah, I forgot to bring x plus 1. Correct. That is how we expand it. So here we are going to have x minus 1 times all this. So let's fill it there. So I have x minus 1 times x exponent n minus 1 plus x exponent plus x plus, correct. So if you expand this, we are saying that the basis of this question is that we take for this question, we say n is an odd positive integer. Yes, I should have attached this to the question, where n is an odd positive integer. So we have that. Now we've had the common factor x minus 1 to both the numerator and the denominator. So let's cancel that one out. So this one will cancel this, and you'll be left with the limit as x approaches 1 of x to the power n minus 1 plus x to the power n minus 2 plus x plus 1. Now, if we put in 1, what are we going to get? We are going to have here as 1 to the power n minus 1 plus 1 to the power n minus 2 plus 1. Plus 1. So 1 to the power this is 1. So here, let's say that if we take n to be, we are saying n is an odd positive integer. So if we start from 1, 1 minus 1 is 0. 1 minus 1 is 0 plus 1, 3 minus 2 plus 1 plus up to 1. So this will give us 1 plus 1 plus 1 plus 1. So let's put our limit there as, okay, we've substituted 1, so the limit has gone. So now, this is what we have. We are having 1 plus 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 1 up to 1. So how do we simplify this? Remember that this is a sequence, and it is a linear sequence. So let's find the sum. The sum will give the answer to our question. And for a linear sequence, we have Sn to equal to n divided by 2 times a plus l. You have the last term and the first term. So here, the last term is 1 and the first term is also 1. So we take Sn to be equal to n divided by 2 into bracket 1 plus 1. Very simple as that. So this will give us n divided by 2 times 2. That's the sum of this linear sequence. So here we have Sn to be equal to 2 cancel 2 and that is 2. So here our answer is n. As x approaches 1, x exponent n minus 1 divided by x minus 1 will also approach n. Wow. Let's take the next example. My videos are very helpful. I think I will be finding them helpful, but they are long. Why? Because I have the passion of solving more questions just to make you understand. So at least if you watch 20 minutes, 15 minutes, 10 minutes of my videos, you see that it will boost your energy for your exams. Okay. So always watch at least 15 minutes and you see that it will warm you up for the exams. Watch at least 15 minutes. I've been doing 1 hour videos, and if you get time, watch the whole 1 hour so that you get to know plenty tricks for solving your exams questions. Now, let's look at this question. We have the limit. Let's look at this question. The limit. Oh, the red marker cannot come in. We've used the board. That is why the whiteboard is now changing to blackboard. Okay. Let's look at this question. We take the limit as x approaches 1. You have x squared minus 2x minus 3 divided by x plus 1 times, oh no, it's not x plus 1, it's x minus 1. That's not the question. The question is 2x squared minus x minus 1 divided by x minus 1 times square root of x minus 1. Yes. This is the question. 2x squared minus x minus 1 divided by x minus 1 times square root of x minus 1. Now, let's put direct substitution. If you put in 1, you'll get 2 minus 1 minus 1. 2 minus 1 minus 1, and that will be 0. If you put in 1, you have 1 minus 1, times square root of 1 is 1 minus 1. So we are going to have 0 divided by 0, because this will be 0. So the numerator will be 0 and the denominator will be 0. It means that x minus 1 is a common factor to both the numerator and the denominator. So what do? We have x minus 1 at the numerator. We have square root. Should we rationalize? No. We have the numerator to be a quadratic expression, so let's factorize that. We have 2x squared minus x minus 1. So you take the constant term, negative 1, because here there's no common term for us to factorize out first. So this is negative 1. Then we find the factors of negative 1. Oh no. We multiply the coefficient of x squared, that is 2, by the constant term, negative 1. To get negative 2. So we find the factor of this negative 2 such that when we add it will give us negative 1. And that one is negative 1 and positive 2. Wow, positive 1 and negative 2. Because positive 1 plus negative 2 is negative 1. And that's the coefficient of this. So for this, we're going to get 2x squared minus 2x plus x minus 1. Why did I bring the negative 2 here? Because we can factorize it out here, very simple. Okay, so what are we going to get? You have 2x times x minus 1 plus 1 times x minus 1. So x minus 1, x minus 1, so you factorize x minus 1 out, you have 2x plus 1. So we are going to have the limit as x approaches 1. x minus 1 times 2x plus 1, or divided by x minus 1 times the square root of x minus 1. And the common factor will go. So you'll be left with the limit as x approaches 1, 2x plus 1 divided by square root of x minus 1. And now, can we do direct substitution? Let's do and see. We put here 1, 2 times 1 is 2 plus 1 is 3. We put here 1, square root of 1 minus 1 will give us 3 divided by 0. That will be undefined. So if this one happens, how do we go about that? Can we rationalize the denominator? This is what I'm going to do for lesson 6. This is lesson 5. Lesson 6, we'll be looking at evaluating limits involving square roots. So when you reach there, but it will not be there. But here, if you rationalize the denominator, you will still get x minus 1. That is, if we take 2x plus 1 divided by square root of x minus 1 and multiply here by square root of x plus 1 and here by square root of x plus 1, that is the conjugate of x minus 1 is the square root of x plus 1. So you multiply by the numerator and multiply by the denominator. So here we get 2x plus 1 times square root of x plus 1 divided by square root of x times square root of x will give us x. Negative 1 times 1 will give us negative 1. You will still have x minus 1 and division. And if you put in x equal to 1, you get division by 0. We will do this in the next lesson, so we shouldn't worry ourselves. Now, if this happens, then we are going to use the product rule. So this is the same as the limit as x approaches 1, 2x plus 1 times 1 divided by square root of x minus 1. So from the product rule, we take the limit. The product of the limit is the limit of the product. So we take the limit as x approaches 1, 2x plus 1 times the limit as x approaches 1, 1 divided by square root of x minus 1. If we put in 1 here, we are going to get 2 times 1 plus 1 and the limit as x approaches 1, 1 divided by square root of x minus 1. And this will give me 3 times the limit 1 divided by square root of x minus 1 as x approaches 1. Now here, we still have division by 0, which is undefined. So what we are going to do is that we are going to find one-sided limits for this function. So you find the left-sided limit, and then you find the right-sided limit, and then after that we compare to see whether the limit exists or not. So we are going to consider the limit of 1 divided by square root of x minus 1 as x approaches 1, that is positive 1 from the right hand side. Then after that, we look at the limit as x approaches 1 from the negative side, from the left side. So let's see. Let's take positive 1. Now, if x is approaching positive 1 from the right, then it means that we are going to take values from the right of positive 1 that is very, very close to 1. I know that values from the right here are greater than 1. So we take, let's say, 1.000001. You can take 1.00000001 and check, but me, I'm using this. This is very close to 1. This one is also very close to 1. So I'm using this. And take your calculator for us to continue. Now, we are going to put x equal to 1.001. So we have 1 divided by square root of 1.00001 minus 1. So let's point 1 divided by square root of 1.00001 minus 1. Wow. That will give me, whoosh, that will give me 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.5. that will give me a very large positive number. A very large positive number. So this implies that if you put in x equal to this, you get a positive number that is larger or bigger than this. So it means that as x approaches positive 1 from the right, the behavior of this function will be that, or this function will also increase without bound. It will increase without bound, and it will be a positive large numbers. So we say that this function will increase up to infinity. So we take positive infinity. Wow. So that is it. Now, but we have 3 times the limit. So what do we say? We are going to have 3 times the limit of 1 divided by square root of x minus 1 as x approaches positive 1 from the right, equal to 3 times positive infinity. And 3 times a very large number will still give us a very large number. 3 times a very large positive number will give us a very large positive number. So we are going to take the limit as x approaches positive 1 from the left hand side, 1 divided by square root of x minus 1. Now, from the left hand side, it means that we are going to take values less than positive 1. So if we do this and put positive 1 here, on the left hand side, we have, let's say, 0.9999. You can take 0.999999. But I'm taking this. So here we take 1 divided by square root of 0.9999 minus 1. Let's see what we're going to get. So 1 divided by square root of 0. Wow! Wow! This is giving us negative 19999.499999. That is a very large negative number. So if you put in this, it means that you get a very large negative number, larger or greater than this one. So it means that as x approaches positive 1 from the left hand side, the value of the function will decrease without bound to negative large numbers. That is, decreasing means it is moving to negative large. Here, the value increases without bound. Sorry, the values increase without bound to positive large numbers. But here, it will decrease without bound to negative large numbers. So here, we will state that the value of the function will decrease without bound to negative infinity. So if we take 3 times the limit as x approaches positive 1 from the left hand side, 1 divided by square root of x minus 1 will be 3 times negative infinity. So 3 times a very large number will still give us a very large number. So here, if we take the one-sided limit of this, the limit of 1 divided by square root of x minus 1 as x approaches positive 1 from the right is positive infinity, and as x approaches it from the left is negative infinity. So since the two limits are not the same, you see that this one is negative infinity and this one is positive infinity. So since the two limits are not the same, you say that this limit does not exist. The two limits are not the same. Here we have negative infinity and here we are having positive infinity. The two limits are not the same. So you say the limits does not exist. Don't use this in exams, right? It fully does not exist. The limit does not exist. Okay. This one is also a special case under factorization. I've been saying that always watch at least 15 to 20 minutes of every video that I post, and you see that your life will never be the same. It will increase your understanding. Now, what about this one? If we take the limit as x approaches m, 1 divided by m, 1 divided by x minus 1 divided by m, all divided by x minus m. How do we do this one? Let's simplify what we have at the top. Or let's put in m first and see what we get. You have 1 on m minus 1 on m divided by m minus m. That will give us 0 divided by 0. So it means that x equal to m means x minus m is a common factor. We have x minus m here. So let's figure it out at the numerator. So here we take the limit as x approaches m. Here 1 divided by x minus 1 divided by m has LCM mx. So x will divide this m times 1 will give us m. M will divide this x times 1 will give us, we have minus x. All divided by x minus m. Wow. So we are going to have the limit as x approaches m. Now, since we are dividing, if you have a divided by b, x, then you have a times x divided by b. So here, the same one having a divided by b divided by c. So this division sign will be a times, and take c on b. So now this division sign will change to multiplication. I hope that is that. So you take m minus x times m times x divided by x minus m. Very simple as that. So you're going to have the limit as x approaches m. M times x times m minus x divided by x minus m. Wow, we are not getting the common factor. But we've done this one already in the previous example. So I'm going to factorize negative 1 out. So I'm going to have the limit as x approaches m, negative mx times, this one will be negative m plus x, all divided by x minus m. So this one will give us the limit as x approaches m minus mx times x minus m divided by x minus m. And this one will cancel this. So we are going to have the limit as x approaches m minus mx. And this is the same as the limit. You factorize the constant that is negative m out. You have negative m wow. Let's check something. No. This one rather will turn upside down. So we are wrong. Wow. I've caught it very fast. We are wrong. You are wrong. This will be the limit as x approaches m. Yes, this one will turn upside down. So we have m minus x divided by mx times 1 divided by x minus m. Yes. This division will turn to multiplication, and this x minus m, which is divided by 1, will turn upside down. I nearly had it wrong, but so this one is going to be the limit as x approaches m minus x divided by m times x minus m. So you cannot cancel out. So let's factorize. I've done that one already. So we take the limit as x approaches m minus m plus x divided by m x divided x minus m plus x x minus m. So this will be equal to the limit as x approaches m negative into bracket x minus m, just reposition divided by mx times x minus m, and here this and that will cancel out. That's the common factor to both the numerator and the denominator, and we are going to have the limit as x approaches m negative 1 divided by mx. Wow. So here we take the limit of the numerator and the limit of the denominator. So we take the limit as x approaches m negative 1 divided by the limit as x approaches m of x. M is a constant, so I'll factorize m out. So this will give us negative 1, but the limit of a constant is a constant, divided by m times the limit of x as x approaches m is m. So I have negative 1 divided by m squared as our answer. I hope I've solved plenty examples to improve your understanding. I hope I've solved plenty examples. Okay, this is our last example that we are going to solve. Let's solve that last example and you see, bye-bye. Now, we take the limit as x approaches 1. Negative 1 rather. Okay. We have x squared minus 2x minus 3. Yes. Divided by x squared minus x minus 2. So let's do direct substitution. This will give us 1 squared. Negative 1 squared minus 2 times negative 1 minus 3 divided by negative 1 squared minus negative 1 minus 2. So this will give us positive 1, yes, plus 2 minus 3, that will give us 0. This will give us positive 1 plus 1 minus 2, that will also give us 0. So you have 0 divided by 0. Which means that if you have x equal to negative 1, it means x plus 1 is a common factor. So let's figure it out. Okay. So here, both the numerator and the denominator are quadratic expressions. So let's do factorization. Okay, let's factorize simple. X squared minus 2x minus 3. Okay, let's take the limit as x approaches negative 1. So the top one will be x squared. Then positive 1 times negative 3 is negative 3. So you take the factor, that will give us negative 2. You have plus x minus 3x minus 3 divided by this one 2. We have x squared plus x minus 2x minus 2. So learn how to factorize, right? I've not uploaded videos on factorization, but I'll do so later. So we take the limits as x approaches negative 1. X plus 1 minus 3 into bracket x plus 1, all divided by x into bracket x plus 1 minus 2 into bracket x plus 1. Okay. So here, what are we going to get? We're going to have the limit as x approaches negative 1. X plus 1 times x minus 3 divided by x plus 1 times x minus 2. Wow. Yes. So here the common factors will cancel out. So we have the limit as x approaches -1. X minus 3 divided by x minus 2. And upon direct substitution, I have -1 minus 3 divided by -1 minus 2. That's minus 4 divided by minus 3. That is 4 out of 3 as our final answer. You see, x minus 3x will give us minus 2x. Here, the coefficient here is 1. The coefficient here is minus 3. If you multiply, you are getting the minus 3. Here, 1 minus 2 will give us minus 1. And 1 times minus 2 will give us this. So, check your factorization well, and it will help you to improve. Thank you for watching. I'm Mensa Augustine. Please subscribe, like, share, and leave your comments. Don't, let's say, put comments there if there are mistakes. If there are no mistakes too, you can be very grateful to me for providing you this very nice video. But just say thank you, sir, and a whole lot of thanks. I love you all. Bye bye.